This is Colin Trudeau, and I'm here to present this course on translating your Duct Geek knowledge, the importance of becoming a Duct expert. This presentation is part of the NADCA's ASCS Continuing Education Program. By watching this presentation, you will get 2 hours of credit towards your NADCA ASCS Continuing Education requirement that is necessary for you to renew your certification. Upon completion, don't forget to sign and submit your training affidavit at the completion of this course. NADCA has a disclaimer that I need to read before going any further in this presentation. First off, this presentation is not intended to be a comprehensive program covering all aspects of this topic. All participants are encouraged to read and follow applicable standards, codes, and regulations related to this topic. The views and opinions following are the presenter's opinions and not necessarily the official position of the NADCA Air Duct Cleaners Association. We're going to start with the basics here. So when you're talking about a clean and healthy home, we're talking about the HVAC system and how it actually contributes to a comfortable environment. So think of a three-legged stool. There's three main components that you need to look at when you're talking about these elements. So first off, what type of condition is the equipment in? The duct system. Is it sealed properly? Is it working properly? And then you need to look at the overall thermal envelope of the building. And is it sealed properly? And is it doing its job like it should be? So we're going to dive into that a little bit deeper in the next couple slides. So as we're going through this presentation, you have to realize that this presentation was developed by NADCA and is actually for the entire group of HVAC duct cleaners that are out there. A lot of them are already providing equipment. They are already servicing equipment. So when we're talking about the home performance puzzle, we're talking about all of these pieces, even though we may not service equipment, but that is a big piece of the puzzle. But also understanding the thermal envelope of the building and the building science in general actually plays into a lot of what we do when it comes to duct cleaning, as well as when we're dealing with any other type of services that we actually provide, especially when it comes to cleanliness of a facility. So in order to be proficient, we need to understand how airflow works. We need to understand how duct systems work and how they correlate together in order to create a healthy, clean environment. So a good way to figure this out is by doing some testing, which we're going to talk about in the next slide. When you're evaluating condition of indoor environment, whether it be a residential or a commercial property, it's a good idea to have a variety of different tools that you can use in order to evaluate the systems and what is actually going on in the facility. A simple one is a simple camera that you just take, point and shoot, and have some documentation. Something that would cost a little bit more, but it's actually still relatively cheap, is utilizing a smoker. A smoker billows smoke, and you can trace it to see how the airflow flows around registers from one space to another. The other thing that is actually probably more beneficial that we would use on a regular basis is using an IR camera or a thermal camera. This allows us to actually see cool spots and hot spots and identify where there may be potential duct leakage. Now, all that being said, there are more expensive options, including blower doors and duct blowers and things of that nature. Those are items that we typically will not get into, but there are also still good tools to have at your disposal if you ever need them in order to help determine where you may be having issues with the building envelope. Over the next couple slides, we're going to look at how duct leakage impacts the overall indoor environment. So a lot of what we're going to talk about in the next few minutes is going to be about duct leakage. And so starting off, just a few statistics for you. The U.S. Department of Energy basically states that, in general, ducts are going to leak. They are actually built with knowing that they're going to leak. And the problem is, with older ducts, it's not uncommon for them to leak 25 to 40% total. That means 25 to 40% of the air going through the ductwork is not making it to the register. It's actually leaking out through other areas within the system. So duct systems in basements lose less, it turns out, and duct systems that are located in attics actually lose more air. So what is the impact on these houses when you have this much duct leakage and you're actually blowing air into other spaces other than where you actually want the air to flow into? We need to understand what the impact of duct leakage is. So when we're talking about in the summer months, we're talking about comfort inside of a home or inside of a commercial building. What areas are not getting cooled appropriately? If you're talking about a home on the second floor, why is it the rooms up there not being cooled properly? Are you losing some of your cool air into the attic because they are leaking? And if you're leaking air, what it can lead to is you have a very humid home because you're not being able to pull out all the moisture out of the home itself. So let's flip that and look at the winter months. If you have duct leakage, you're not going to be able to get the hot air to the areas you want to, and it's not going to maintain the comfort levels you want to. Therefore, the house is going to have more cold drafts. The house is going to be drier, especially up north where you have humidifiers. It's not working properly, not getting enough humidity into the atmosphere. So now it's a very dry environment with a lot of drafts going through it. The other issue that you run into when you have ducts leaking is not only is it blowing excessive air into attics and into crawl spaces and areas you don't want to, it also can suck air into space from spaces that you don't want it to be sucking from, including attics and crawl spaces. So therefore, you're pulling more dust and debris into the system, and therefore your ducts are getting dirty. The other thing that contributes to that is other indoor air quality issues, which include odors within the facility or within the home. Registers are starting to sweat because now you're pulling in more humid air into the area, and those registers are now creating condensation, which then leads to microbial issues. And you can also lead to CO2 monitors going off at the same time as well. Now, the obvious thing to consider anytime a HVAC unit is working longer and harder because the air is leaking into unoccupied spaces or areas that you don't want it to, the system is going to cost more. It's going to cost more electricity. Therefore, your bills are higher. So if we can decrease even a small percentage of the amount of air that's being leaked into a facility, we can act. And when you're looking at large scale, when you're looking at schools, you're looking at commercial facilities, saving a small percentage of the duct leakage can actually lead to equipment working longer, less maintenance, and obviously spending less electricity. What ends up happening when somebody's house or their building is not cooling the way they want it to, the first reaction is, I need a new system. So you go out there and you buy a new air handler, you buy new condensation coils, and you buy a new condenser, and you put it in, and then the comment is made, it still has the same problem. You didn't fix it, and in some cases, the old system was working better. And that is because it's not the unit that is the problem, it's because of the ductwork. So if it's not the unit that is the issue, then the next thing that you need to look at is what's going on with the ductwork, what's going on with the overall building envelope. Well, that's where, as duct cleaners, we can come in and actually help with this problem. We have the solutions to going in and resurfacing the ductwork, which also can help seal the ductwork and help eliminate some of these problems for our customers. When it comes to duct leakage, there's a couple things that can actually happen. You can be losing air to the outside of the duct system of the building envelope, which means you may be exhausting into the attic or into a crawl space. When this happens, especially on the supply line side of things, you actually put the house under negative, which means you're now sucking in dust and debris from outside, from areas that you don't want it to be sucking air from in order to create a balance in the system. The other option is if you're leaking out air to the inside, it throws the balances off in the system. So you may have one area that is cooling better, but then you have another area that's not getting the air that it needs to. So you need to look at both of these. So it's not just a matter of how the air flows from one space to the other or the fact that it's actually leaking. You need to make sure the entire system is balanced in order to have a properly functioning system. Over time, duct leakage will start to add up. Duct systems that have holes in it, which are subjected to mechanical pressures, and this always happens at the worst time of the day or the year, they will end up losing the most conditioned air via the supply leaks, which then in turn often sucks the hottest possible air into the return leaks and may cause bringing in additional unwanted humidity. Often it's not just one big duct issue that you have where it's leaking all your air. Often it's a bunch of little tiny things that are all over the place. You look at the picture on the left right here, you can see the connection box from the plenum to the ductwork itself. It's not sealed. And the same thing with the picture in the middle. All that air is able to escape, and you have a bunch of little pockets of air that are escaping, which creates all kinds of issues. Everything from condensation issue, which you can see the rust starting to form on that, all the way to the air not being channeled where it needs to. So all these little leaks all over the place all need to be addressed. You tighten those up, and it really starts to add improvement. But you have to address all of them. Now, the other reason why doing inspections is extremely important when you're dealing with HVAC systems and you're trying to determine why things may not be working properly is you have to look to make sure the system is put together properly. These are perfect pictures of situations where duct has been knocked loose for one reason or the other, and it is just completely disconnected. And that could be a big reason why you have your leakage, obviously, and also why specific areas are not cooling. So you need to keep an eye out when you are working in residential properties or even on commercial properties for these exact situations so that they can be addressed. And then you have to be aware of situations where it's not even a duct at all. All it is a cavity in a wall that's being sucking air through, and especially when it's being used as a return duct, what can happen is now those return ducts leak dramatically, which pulls in all kinds of excessive dust and debris into your system that you do not want. And if your filters are not working properly, this is where it can become a really major issue, especially when you're dealing with air quality within the facility. Those of us that deal with basements will actually see a whole nother set of problems. When you're dealing with supply ducts inside of a basement, it is possible you could have all kinds of different leaks that are going on down there. And anytime that you do have leakage, it's going to create all kinds of comfort problems. And especially this is a really big deal when you're dealing with summer humidity issues. What you're looking at here is an actual report from a 2-story home with a finished basement. And what you're seeing is you can see the blue line go up and down, up and down. That is the upstairs portion of this home that fluctuated greatly because there was a lot of duct leakage. The pink line directly below it, you can see how not only were they able to drop the temperature in the house by fixing the duct leakage, they are also able to lower or minimize how much the air temperature actually jumped up and down over a period of time. Same thing happened in the basement when you look at the yellow line versus the teal line. Now, what I was referring to the 20-point spread is the fact that at one point you had a 20-point spread between the upstairs and the downstairs. After the duct leakage was addressed, they were able to decrease it so it was only an average of about 3-degree difference between the two. A huge dramatic improvement of the system just by fixing the ductwork. There are other problems you can run into associated with airflow and imbalances. And the big one is when you have a central return in a home or in a business and you have door closures. When they did not take the fact that doors are being closed into account when they designed the system, that air now does not flow the way it should. And that creates a big imbalance within the entire HVAC system. The other thing that, of course, you got to look out for is poor insulation on the ductwork itself. Obviously, if it's not insulated properly, the air is not going to be able to maintain its temperature, whether it's trying to cool or trying to heat all the way through the duct run. It's going to have a tendency to lose some of that thermal efficiency. Some of the other issues you can run into associated with duct problems is very low airflow because things are not maybe disconnected or a variety of different reasons or blocked potentially. Noise caused by high velocity or from the blower running at high RPMs, and the system was never tested or balanced properly whenever it was installed. Before we go any further, I want to take a minute and discuss the effects of duct leakage and how that affects the indoor environment. When we are talking about duct leakage and we're talking about airflow inside of a building, I like to use the analogy of basketballs. And the reason why I like to use that analogy is because a basketball is about 1 cubic foot. It's about 12 inches by 12 inches by 12 inches. So if we're talking about air pressure within the building and we have 1,000 CFM that are going to return, and then it goes through the unit and it comes 1,000 CFM are coming out of the supply, then the system is going to be in perfect balance. It's not trying to pull air or push air from any other areas other than within the building envelope itself. So let's use that as a basis as we start discussing some of the next couple slides. The last slide that we looked at showed that the system was completely balanced. You had 1,000 CFM going into the unit, you have 1,000 CFM coming out of the supply side of the unit. So the other option you have is the fact that you may have 1,000 going into the supply. You may be pulling additional from the return side of the system. Then you also have 1,000 coming out of the supply, but you may be losing a little bit of leakage. If you're losing the same amount as you're sucking in on the return as you are in the supply, this system can still be a neutral pressure, meaning you don't have any negative air going on in this situation. This illustration actually shows a perfect example of what happens when you have supply duct leaks. If you have 1,000 CFM, 1,000 basketballs that are going into the return side of the unit, 1,000's got to come out the other side of it. It's going to automatically push it out. But if you're losing 300 of those into the basement and you're only putting 700 CFM or 700 basketballs back into the house itself, well, the system's still going to pull out another 1,000. So where's that going to come from? It's got to come from somewhere. This is how you get into a negative pressure system. If you are losing air on the supply side of things, now you're pulling air from the attic, you're pulling air from the basement, you're pulling air from outside, and it's often that air is not very clean when that happens. So therefore, you greatly diminish the quality of your indoor air quality. The question you have to ask yourself is, where is all this air going to be coming from, and what is it going to contain? What kind of dust and allergens are going to be coming from the outside? What kind of heat and humidity are you pulling in from the attic because you have duct leakage and you got the building under a negative pressure? What kind of cold and dry area would you be pulling in during the winter months, especially from a crawl space or from another area that may have all kinds of contaminants in it? One of the biggest issues you can run into is when you start talking about backdrafts and gas appliances and CO2, because if the system is not allowing, it's not in neutral, and it's allowing those gases to escape through chimney flues or through exhaust flues, then what can happen is that CO2 or the smoke or soot can actually be drawn into the house and create a problem that way as well. We just talked about what would happen on the supply side of things and how you create a negative pressure inside of a building whenever you have leakage on the supply. But what happens when you have leakage on the return side of things? What you're going to do is actually have a tendency to pressurize the entire facility. So what happens with that, you may actually have less dust being sucked in and less allergies being sucked in, depending on where that makeup air is coming from. But a lot of other issues can arise from these circumstances as well. Take a look at this diagram here. You can see 1,000 CFM being being sucked into the return, but it's also sucking in an additional 300 CFM from the attic space. And so what happens now, while we have 1,300 CFM coming out into the building, and now we have everything pressurized. So this is a home, and it may not be as big of a deal, depending on what you're pulling in from the attic, if you pressurize in the home because you're not drawing in allergens and other things from outside. But think of a commercial building. What happens to spaces if you have a unit that has this situation, you have positive pressure going on? You may be pulling odors from a kitchen or from other odors and other smells and everything else from one unit and pushing it to another unit and other occupants that may not be welcome to those odors and those smells. Over the next few slides, we are going to discuss how air exchanges and air infiltration can affect the indoor air quality. There are two main driving forces that cause air infiltration to a building. First is wind, and wind is affected as the winds increase, they get higher. What ends up happening is as the air blows over chimneys, blows over vent stacks, and even blowing air up into the attic can actually create positive and negative forces on the inside environment that can actually start sucking air from outside into the home. The other thing that is mentioned here is stack effect. What that is, that happens even more so in taller buildings, is as the air heats up, it has a tendency to rise. And as the air rises, it has a tendency to create a vacuum or suction from the lower floors. And this happens primarily on taller buildings. That's why if you go into a skyrise building, you'll actually know that there's revolving doors at the bottom, and those are actually in place to help reduce stack effect. Now, the other thing that can happen is from mechanical driving forces, which we'll talk a little bit more in a few minutes, and that can include doors or just changing how air flows through the facility, and also caused from air leakage as well. There was a study that was conducted in Florida where they took a variety of homes that varied anywhere from brand new up to 40 years old. They actually did this over several hundred homes, but then they took a sample size of those, about 160 random homes, and created a study. And what they found is even with the HVAC system turned off, so there's no mechanical means pushing air through the home, there were still air exchanges occurring, and that was because of the effects that we talked about earlier between the wind and the stack effect causing pressure differentials. That actually they came up with about zero point 0.3 air exchanges per hour just by the house simply sitting there. Now, obviously, older homes have a tendency to leak because they're not sealed as well as newer homes, but on average, on 160 homes, they had about 0.3 air exchanges per hour. The previous slide, we just established the fact that out of those 160 homes, they were getting about 0.3 air exchanges per hour. What they then did is test the homes again after the AC or HVAC system was turned on, and they actually discovered it was about almost a full air exchange every hour by the system being on. So what is causing these air exchanges, and why would it be increasing with the HVAC on? Well, we'll look at that here in the next few slides. We talked about it earlier that as the wind blows up against a house, it creates a high pressure on the windward side of the house and negative pressure on the leeward side of the house. Also, you start bringing in chimneys and other orifices, it starts creating a suction effect or a vacuum effect associated with those holes and gaps as well. Well, what about the mechanical side of things? Again, that plays into duct leakage. And like we discussed earlier, depending on where the air is leaking, you're going to create positive or negative effects in the home. And the system is out of balance, it's going to create more problems. You shut a door that is supposed to have air flowing through an opening, because that's the way the system was designed, it can create vacuum effects in the home as well. And we'll look at that here in just a couple slides. We already established that natural forces causes about 0.3 air exchanges, at least it did on these 160 houses. And when you turn the HVAC system on, you got another almost a full air exchange every hour. And then through this study, they started closing doors and disrupting the airflow through the home. And they actually saw a 600% increase. And so that you're getting almost 2 air exchanges per hour because of just the disruption of the airflow and the way it naturally flows through the home. Let's take a look at this picture here. In this particular case, you have 2 rooms, and the system is designed for the door to be open so air can easily pass between one room and the other room. If you were to close that door, what you have is on one side of the system, you have a positive pressure, and on the other side, because it's not getting the makeup air it needs to, you now have a negative pressure in that room on the left. So that air has to come from somewhere. So it's going to start going through cracks in the windows. It's going to start pulling air from the attic space because of gaps that may be around lights and other registers and other things of that nature. So the air is getting made up from somewhere. So now you get questioned, what kind of air are you bringing in? Are you bringing in dirty air? Are you bringing clean air in? This is what happens when you have a house with a central system, especially with a singular return, and you don't get the adequate airflow because you've restricted how it moves through the home. So one way that you can actually rectify this situation is by creating jumper ducts. And they're not actually ducts connected to your HVAC system. What they are is actually just connected to the 2 rooms. So if you have a hallway, like in this picture here, and you have a doorway that's shut, what it does is it allows that air to easily flow from the bedroom on the left to the bedroom on the right. So if you come across a house and you happen to see one, this is what it would look like. You can actually see in this picture here, it literally just goes up into the attic and back down again on the other side. It's that simple, and it helps to improve the airflow between the 2 areas. Here's another example of a jumper duct where you may have the grill high inside the bedroom, so that can't be blocked by furniture, and then it comes out low on the other side as it flows into the hallway. Now, the way this would have to be set up is the drywall in the cavity itself would have to be completely sealed, including the drywall being glued directly to the wall to make sure you have a good, tight envelope as the air passes through. And then here's just another one where you may actually use the floor joists or the dead air space between the 2 floors to allow the air just to go up and over the wall cavity itself. So in summary, essentially, if you have a situation where you have air that is not flowing easily from one space to another space, utilizing jumper ducts or even utilize active returns, open air return systems can help greatly increase the air pressure and help minimize the hot pockets and cold pockets you may otherwise have in a facility or within a home. Over the next few slides, we're going to take a look at how you can actually demonstrate duct leakage and show your customer that they may or may not have a problem. I will tell you that there is no magic bullet to the exact way that this needs to be done, but you do need to be able to demonstrate the fact that they have duct leakage and show them that they have it. You need to make sure you have a means of measuring it, and there are times that you'll actually want to do both, and we're going to take a look at a few of those options. So one of the most important things you need to do in order to get buy-in is to have the customer actually see that they actually have duct leakage. And utilizing smoke to do this is one of your best options. So there are a variety of different ways you can do it. You have machines that create smoke. You have little puffers. There's whatever you end up using, but all you have to do is literally create the smoke and then watch how the smoke either reacts, whether it's air being infiltrated into the home or into the building. You can see it moving that way, or you can also see it being sucked out as well. So there's a couple different ways you can actually utilize the smoke, but one of the first ways is to start with the AC with the fan actually on and blowing and go around to the different connections. And you can actually, by holding it up to the connections, you can actually see how the air is blowing around. You get up into the attic, you can actually start to see how the air is penetrating and being sucked into the home as well. And the homeowner a lot of times can actually see it being sucked and blown into these spaces as well. So anywhere that you may potentially have a leak, look for dirty insulation. That may be a telltale sign that you have airflow or air movement in that particular area. And so just take a little bit of smoke and watch how it flows, and that will help identify the areas that maybe need to be repaired. So one of the more sophisticated ways of doing this is by utilizing a blower door. What a blower door does, you actually basically take the door opening, put an exhaust fan essentially in it, and so you're sucking all the air out of the home. And what you can then do is go around to anywhere there may be potentially an opening and actually start measuring all those different leaks, utilizing either smoke, or a lot of these blower doors actually have computers that allow you to determine how much air infiltration you actually have coming into the home. If your HVAC system is tight and there is no duct leakage, when you put on a blower door, you should not be getting any air in or around the registers themselves. So even going to the return with the unit turned off, you should be able to hold smoke up to it, and if you see air being pulled in or if you see air being blown around the register, then you know that the register itself needs to be sealed. And again, if your system is turned off when you're utilizing this, and you go to a register, for example, this one, a floor register, and you hold smoke up to it and you see airflow, well, that tells you that you have a leak in the system somewhere, and you're actually pulling air through the ductwork, which you shouldn't be able to do if the system is sealed tightly. So this is signifying that you have a leak somewhere near this actual register, which will help you identify where you need to go and basically seal those leaks and make sure that it is sealed properly. Like I mentioned earlier, when you use a blower door, the system is actually set up where there are different tests that you can run, whether they be subtraction tests or just different leak tests that you can actually run utilizing computer software to help tell you how much leakage you have within the home. Then after you make the repairs, you can actually go back and run the test again and show the improvements. And that gives you a good way to show the homeowner that you have actually improved their home, or even a facility owner that you've actually improved the building envelope and tightened up the building envelope for them, which will ultimately lead to less duct leakage and lower utility bills. Now that we've talked about duct leakage and how it works, let's take a look at some real-life examples and what the end results were with those repairs. So let's take a look at this example. In this particular situation, we have a 2.5 ton AC system. And if you make the assumption that you can get about 400 CFM per ton, then the system should be able to push right around 1,000 CFM. So in this scenario, we have major leaks in the attic. And what they did is they actually went through and completely sealed the system 100% on both the supply and the return side of it. So let's take a look at this example. In this particular situation, we have a 2.5 ton AC system, And if you figure that you should get about 400 CFM per ton, this system should be able to produce about 1,000 CFM. In this scenario, we have a ECM motor, which is also known as a variable speed motor. And in the house, before they actually did any type of sealing, they had about 800 CFM coming from the house and 200 CFM coming from the attic. Of course, that passed through the coil and then back into the house again. After they were done sealing everything, you actually had zero air coming from the attic itself, and 100% of the CFM, the 1,000 CFM, was actually coming from the house, through the return, going through the coil, and back into the house. The airflow before all the improvements were made was actually okay, because you still had 1,000 CFM flowing into the home. But the problem is you had the motor was working harder because it had to run longer before all these improvements were done, because it was pulling air from the attic that was having to be conditioned before entering into the house. So even though the airflow stayed the same overall, the net effect was still positive. And actually what you ended up getting, the issue they had is they had more airflow coming from the return, so it actually created some noise, which led them to having to increase the actual return itself. But the biggest benefit is you had lots of improvements on overall energy efficiency, because the system did not have to work as long or as hard to condition the air like it did before. So overall, it was an improvement for them. By going through this, I hope you got a general idea of how duct leakage can affect a home or even a commercial facility, and how it can have adverse effects on indoor air quality. There are several options out there for improvements, and I hope you understand by improving it, you can increase the energy efficiency of the system and improve the air quality within a facility. If you have any questions, please don't hesitate to reach out to me. Otherwise, thank you so much for participating.